Hi students, this is Miss Cave with a lesson on finding y-intercept and writing equations from tables, graphs, and written descriptions. So far, if you look at our title slide, we have been learning about slope. And slope is we use m for slope. And the way we calculate slope is our rise over run between 2 points on a graph. So if we look at this graph over here, we have, they've done it on the right, but I'm going to show you on the left. So I'm going to go up 3, that's my rise, over 3, that's my run. So for this, if I was writing an equation, it would be y equals 1, because 3 divided by 3 is 1x. Okay, but if you notice from this graph, it's not proportional. It's not proportional because the line does not hit the origin. So we learned for graphs to be proportional, they must hit the origin. So this is an example of a graph that does not hit the origin. What we're noticing is that instead of starting at the 0, 0 point, the graph is actually starting at 0, 4, and that is our y-intercept. And that's what we're going to be learning how to find from a graph and how to put it into our equation. So y-intercept, we're going to use b to represent y-intercept. And in this case, our b is 4, okay, just by looking at the graph. And our slope is 1, so if we're writing our equation, y equals x, because it's just 1, and then we're starting at 4, so it's plus 4. Now that's just a brief overview of what we're going to be doing today with a graph, and we're going to look at this in terms of tables, graphs, and also written descriptions. So you guys have a foldable in front of you. I want you to grab that foldable. Yesterday we were working on some tasks in class, so you actually were doing examples of how to find y-intercept or how to graph additive relationships. So we were looking at proportional relationships, and today we're going to be looking at additive relationships. All right, so let's get started. First we have an equation. Okay, so to find the y-intercepts of an equation, we're just going to examine this here. Our format for an equation for slope-intercept form is going to be y equals mx plus b. If you look at this equation, you'll see that the slope is 1, so slope would be 1, but something else is happening. So in order to get y, we're adding 7 to x. That number that we're adding is called the y-intercept. So the y-intercept in this equation means, what this means is our graph, if we were graphing this, our graph is going to start at 0, 7. So our y-intercept is 7. So the way we would write that, that's our equation. Okay, our equation is y equals x plus 7, and our y-intercept here is 0, 7, because it's starting at 7. That's the number that we're adding. Our y-intercept is the number that we add. All right, let's take a look at a table. Okay, we've looked at a graph a little bit, we've looked at an equation, and now let's look at the example that you have for a table. So before, when we were looking at tables, we were trying to determine whether they were proportional or not. So we'd be looking for relationships. So I might look for the relationship between 4 and 8. Okay, times 2, right? It looks like a times 2 relationship. But then when we get to 6 and 10, we notice that that's not a times 2 relationship. So if it's not a times 2 relationship and we're looking at additive relationships, we're comparing additive versus proportional, well, the first thing we can do is try to see, okay, well, what else might be happening between the numbers? What kind of pattern is happening? So what am I doing to x to get y? So I'm going from 4 to 8, I'm going from 6 to 10, I'm going from 8 to 12, I'm going from 10 to 14. So it's probably easy for you to see what's happening here. We're not multiplying by 2, but rather we're adding 4. So each time x is entered into the function rule, or function machine as it were, we can see that we're adding 4 every time. So since we're adding 4, the number that we add is our y-intercept. Because our graph is not proportional, it's going to start at that number 4. So our y-intercept is equal to 4. And our equation then, remember I told you that b is our y-intercept. So to write our equation for this, it's going to be y equals, okay, we are, for this lesson, we're assuming that slope is 1, and I can prove that slope is 1. I can look at the change in y, which is 2, and the change in x, which is 2. So slope is equal to 2 over 2. So slope is equal to 1. So when I'm writing my equation, it would be y equals, since slope is 1, I just need to write x. And our y-intercept, the number that we're adding, it's the number we're starting from, is going to be 4. So it's going to be y equals x plus 4. That's our equation. That's how you get it from a table. Just like with slope, we were looking for the multiplicative relationship, and we plugged in m. Now we're going to plug in b. Again, this is our equation, y equals mx plus b. All right, let's look at another example. Okay, so now we're looking at a graph, okay, and then we'll look at the written description. So looking at this graph, you can see it does not hit the origin, okay, so I know that it's not proportional. And I want to identify the y-intercept, and I want to write an equation. So to get the y-intercept is where the line meets the y-axis. Because it's our starting point. It's the number that we're adding. So when we have 0, okay, so if you look at this point here, this is our starting point right here. The coordinates of that point are 0, 1. That's where the graph is starting. It's our starting point. This would be like the cookie problem that we did. If someone started with 1 cookie and then they added on 1 per day, this is what the graph would look like. It's not proportional, but it is a linear function. So the place where the y, or the line hits the y-axis, is called the y-intercept. And so we call that b. Sorry, our smartboard's not working well. B is equal to 1. Okay, so that number, that place where it hits, is called the y-intercept. It's our starting point of our graph. Now you guys could also notice that the slope, if we're calculating slope, it's rise over run, so it's 1 over 1. And for all of these examples, our slope is going to be 1. All these examples I'm showing you. So you're not going to be having to calculate slope and do your y-intercept at the same time. But let's verify that the slope is 1. So now if I put this into an equation, y equals, it's mx plus b. Remember, this is additive, so we're adding something. My m is 1, so I'm just going to write x. And then my b is also 1, because that's the starting point of the graph. So this would be the equation for my graph. It's not proportional, it's additive. It's an additive relationship. So that means every time I increase my x value, I'm also increasing my y value. Okay, let's look at a written description. This is kind of like going back to the cookie problem. So for this problem, we're going to say Caitlin had $2 saved and she earned $1 per week. Okay, sometimes it's going to be difficult to figure out so when we have a written description, sometimes it's helpful to make a table and see what's going on so that we can come up with our equation and our y-intercept. So what this is telling me is that Caitlin had $2 saved and she earned $1 per week. So I'm going to start with a table. X will represent the number of days. Y will represent the number of dollars that she has. So if I start with, I'm going to start with 0. Okay, so after 0 days, how much money had she saved? Okay, so it tells us in the problem that she already has $2 saved. So at 0 days before she started saving, she already has $2. Okay, and so then after 1 day, it tells us that she gets $1 per week. So she gets $1 per week. So now after, oh, this is not days. I apologize. That should be weeks. She's saving per week. Okay, so after week 1, she's going to have $3. After week 2, she's going to have $4. Okay, so what you can do here is you can look at the pattern and see what's happening. So we're going up. Again, if we wanted to look at the slope, we could see that the difference between 3 and 2 is 1, and the difference between 1 and 0 is 1. That's our rise over run. So our slope is 1. And that slope from the problem is the amount that she's earning $1 per week. That's our slope. Okay, and if she just earned $1 per week and she started with nothing, this would be proportional, but it's not. So our y-intercept is going to be what she started with. So our y-intercept is the starting point of the graph, or it's the place, it's the value of y when x is 0. So our y-intercept is that 2, because she's starting with $2. That's our y-intercept, the amount she's starting with. It's not proportional, so now we've got a starting point. So our y-intercept is going to be 0, 2. That's where the graph hits the y-axis. And for our formula, or our equation, we use that second number. We're looking at the place where it hits the y-axis. What number is it hitting the y? So when I go to write my equation, it's going to be y equals, okay, my slope is 1, so I'm just going to enter in 1. For x, just leave x by itself, and then I'm going to add 2. 2 is our starting point. It's the amount of money that she started with. Okay, and then I can look back and check it. Let's see. 0 plus 2 is 2. 0 plus 2 is 2. 1 plus 2 is 3. 2 plus 2 is 4. It looks like it works. So we can put in our values from our table to be sure that our equation is correct. Okay, so if you guys need to pause the video at any time, please do, so that you guys can get all caught up. And what I'd like you to do now is go on and try this equation. So let's pause the video here. Please have someone in the room, our teacher today, to pause the video and try this equation. And then when you're finished finding the y-intercept, please unpause the video. All right, for this problem, we have y equals x minus 2. And remember, our formula is y equals mx plus b. Okay, we know that our slope is going to be 1, right? Because there's nothing in front of the x. And then our b is actually negative 2, because we're subtracting 2. So here, our y-intercept is the number that's being subtracted. So our y-intercept is going to be 0, negative 2. That's the place where this would hit the graph. It would hit the graph at the y at negative 2. All right, go ahead and pause again, and let's see if we can identify the y-intercept and write the equation from the graph. And then when you're ready, unpause. All right, we learned in the last example that the y-intercept is the place, or the last graph example, is the place where the line hits the y-axis. So this is our y, and it's hitting it right here. So our y-intercept is 0, 3. That's our starting point. And then the number that we put into our equation we call b, b for y-intercept. So we're going to write our equation. Y equals, it's mx, right? But let's see, it is a slope of 1 over 1. So it's just x. And then we're adding 3. So now we've written our equation. So instead of just having, it's not a proportional relationship, it's not going through the origin, but it is a relationship. We're adding 3 each time. You can see we have 0, 3, 1, 4, 2, 5, 3, 6, so on and so forth. All right, next example. Okay, we have a table again. In this table, you're looking at the relationship between x and y. So let's go ahead and pause the video. And while we're paused, let's see if you guys can come up with the y-intercept and then the equation. So pause the video and see if you guys can do that from the table. All right, for this table, we're looking for the relationship again between x and y. We're always looking for relationships, whether they're proportional or additive. And we can see that -5 to -8, -3 to 6, -6 looks like a times 2, but there's no other times 2 here. So what's happening from -5 to -8, -5 minus 3 equals -8. So -3 minus 3 equals -6. -1 minus 3 equals -4. 1 minus 3 equals -2. So that minus 3 is our additive relationship. We can still call it additive because we're adding a negative. Okay, so we're adding a negative here, which is the same thing as subtracting 3. So our y-intercept here would actually be -3. Okay, because we're taking 3 away. If it was +3, the numbers in the y column would be going up. And for our equation, y equals, again, I can verify that my slope, okay, -6 minus -8 is 2. -3 minus -5 is 2. So my slope is 1. So y equals 1x. And then this time, instead of adding, I'm subtracting 3. You could also write it as plus a -3. It's still the same thing. But that would be our equation for the graph. And we're going to be doing a lot of practice with this next week. All right, last problem, written description. I want you guys to identify the y-intercept. And I also want you to write the equation for the graph. So go ahead and pause your video and do that. And then unpause when you're ready to check your answer. All right, for this problem, we're given information that Jack is 4 years older than Jill. So he's 4 years older than Jill. And Jack, we're going to use to represent, we're going to represent that by y, and Jill is going to be x. Okay, because Jack is, so 4 years older than Jill. So again, our y-intercept, if we wanted to make a table to represent this, this would mean before Jill was even born, Jack was 4. Okay, so this is Jill, and then y would be Jack. Okay, so before Jill was even born, Jack was 4, and when Jill was 1, Jack would be 4 years older, so 5. When Jill was 2, Jack would be 4 years older, for 6. So you can see the pattern in the table, and we also see it in our description, 4 years older. So our y-intercept comes from here. The value of y when X is 0, or the age of Jack when Jill is not born yet, or she's 0. So the y-intercept here is going to be 4. And if I want to put it all into an equation, I can do that. It's y equals mx plus b. In this case, we can look at our change in y. 6 minus 5 is 1. 2 minus 1 is 1. 1 over 1 is 1. So it's definitely a slope of 1. So it's x plus 4 is our equation. All right. I hope this is sinking in. I know we've been spending so much time on proportional relationships, so it's a little different to be switching over to addition. But we'll be doing some more practice next week with addition, and we'll also be putting them both together and being able to identify proportional or not proportional, and being able to identify y-intercepts and slope from equations, graphs, and verbal descriptions. That's it. Have a great day.